What if I told you there's a volcano near millions of people and scientists are watching its every breath, but not in the way you think? Forget lava flows and eruptions for a moment. Today, we're taking you deep inside Solfatara to reveal the hidden signals scientists are actually monitoring, the silent clues that could predict its next move and why it's more crucial than ever. Volcanic activity is often portrayed in grandiose images of flowing lava, explosive eruptions, and ash clouds darkening the sky. But when it comes to studying volcanoes, especially one as unpredictable and volatile as Solfatara, scientists are focusing on the subtle signs beneath the surface, things that most of us never see. From gas emissions to ground deformation, the real monitoring happens far from the view of tourists and passers-by. Today, we're going to explore what's actually being measured in and around Solfatara, how scientists are tracking its every movement, and why these silent signals are so critical to understanding its behavior. This is the unseen world of volcano monitoring, and the stakes couldn't be higher. What if everything you thought you knew about volcanic monitoring was just the tip of the iceberg? The public perception of volcanoes, especially Solfatara, tends to focus on their dramatic displays of molten lava, pyroclastic flows, and cataclysmic eruptions. However, when scientists approach a volcanic system like Solfatara, they're focused on a completely different set of data. The real story isn't found in the eruption, but in the signals leading up to it, the subtle, often invisible clues that provide a window into the volcano's behavior. Solfatara, part of the Campi Flegrei Caldera near Naples, Italy, is an active volcanic system with a long history of geothermal activity. It's famous for its steaming vents, sulfuric gases, and bubbling mud pits, which seem like the obvious signals of volcanic activity. But beyond the visible steam and gases, there's a much deeper, more complex web of monitoring occurring beneath the surface. Unlike surface eruptions, which are dramatic and often easily detectable, the real danger in places like Solfatara lies in the subtle changes happening beneath the Earth's crust. That's where scientists are concentrating their efforts, tracking shifts in the ground, measuring gas emissions, monitoring thermal anomalies, and studying changes in the soil and water. These are the signals that could give us a much clearer understanding of when Solfatara might awaken with catastrophic force, or if it is simply experiencing a normal phase of volcanic activity. One of the most critical factors scientists monitor at Solfatara is the release of gases. Gases like carbon dioxide, CO2, sulfur dioxide, SO2, and hydrogen sulfide, H2S, are constantly emitted from the volcano's fumaroles, the vents through which geothermal steam and gases escape. While these gases may seem harmless at first glance, they're actually some of the most reliable indicators of volcanic activity. Increased levels of carbon dioxide, for instance, can indicate that magma is rising closer to the surface. As magma moves upward, it brings gas with it, which causes a change in the gas concentration. A sudden surge in carbon dioxide could indicate that pressure is building within the magma chamber beneath Solfatara, signaling potential future eruptions. Similarly, the release of sulfur dioxide is linked to volcanic processes, particularly in areas of high heat, where the sulfur is released from molten rock and gases trapped beneath the surface. But why are these gases so important? They provide an early warning system. While they might not cause immediate danger to tourists visiting Solfatara, higher concentrations of these gases can indicate an impending change in the volcano's behavior. Scientists track the flow of gases continuously, using sophisticated sensors and air sampling stations placed strategically around the site to detect changes in emission rates and gas composition. By analyzing the concentration of gases, scientists can determine the health of the volcano. Anomalies in the patterns of gas emissions can reveal when a volcanic system is becoming more active and when there is a possibility of larger eruptions or shifts in the underlying magma reservoir. These emissions serve as the volcano's breath, a vital sign that can tell us a lot about its activity, often well before the public is aware of any significant changes. Another critical factor in monitoring Solfatara is ground deformation. The earth beneath us is far from static, especially near active volcanic regions like Campi Flegrei. As magma moves beneath the surface, it creates pressure that can cause the ground to stretch, crack, or shift. Ground deformation is closely monitored using a variety of tools, including GPS stations and satellite radar systems. By installing GPS sensors at various points around Solfatara and the surrounding caldera, scientists can track the very subtle movements of the Earth's surface. These measurements can detect vertical and horizontal shifts in the ground, even if they're only a few millimeters in size. Over time, these shifts accumulate, providing valuable insights into the pressures building beneath the surface. Changes in ground elevation are a crucial part of understanding how a volcano behaves. If the ground begins to rise or fall in a particular area, it could be a sign that magma is moving beneath that part of the caldera. This process, known as uplift or subsidence, can be indicative of volcanic unrest. A rise in ground elevation could indicate that magma is accumulating beneath the surface, while subsidence could suggest that magma is withdrawing, potentially leading to an eruption or a collapse. Even small shifts in the ground can be an early warning of larger, more dangerous events. By monitoring ground deformation, scientists can get a clearer picture of what's happening beneath Solfatara and whether these movements suggest an impending volcanic crisis. Temperature is another crucial factor in monitoring Solfatara. The ground, fumaroles, and water sources in the region are constantly being measured for changes in temperature. This is because increased thermal activity often correlates with increased volcanic activity. Thermal cameras and infrared sensors are used to detect temperature changes in real time. These sensors are capable of measuring the heat emanating from the volcano's surface, including its fumaroles, cracks, and hot springs. If the temperature begins to rise in certain areas, it can indicate that magma is coming closer to the surface, heating the ground and surrounding environment. In addition to providing insights into potential eruptions, thermal monitoring can also help scientists track the evolution of volcanic gases. As temperatures rise in specific areas, gases are released at higher rates, potentially signaling increased volcanic unrest. This combination of thermal and gas measurements gives scientists a more comprehensive view of the volcano's behavior and potential for eruptions. By tracking changes in temperature, scientists can detect early signs of increased volcanic activity and make predictions about future eruptions with greater accuracy. Solfatara is located in one of the most seismically active regions of the world, and seismic activity plays a major role in understanding the volcano's potential. Seismographs and other monitoring devices are used to measure the tiny tremors and quakes that occur beneath the Earth's surface. These tremors, often imperceptible to humans, can provide critical information about the movement of magma and the behavior of the volcanic system. Even minor seismic events can indicate that magma is moving beneath the surface, causing pressure to build up. These movements, known as volcanic tremors, are often signs of increased volcanic activity. And when combined with other data, such as gas emissions and ground deformation, scientists can get a clearer picture of the volcano's internal processes. In recent years, scientists have also started using advanced techniques like real-time seismology and microseismic monitoring to detect subtle shifts in the Earth's crust. These tools allow scientists to monitor Solfatara's seismic activity continuously, providing up-to-the-minute data that can be used to track changes in volcanic behavior. The true power of volcanic monitoring at Solfatara lies in its integration. No single measurement, whether it's gas emissions, ground deformation, temperature, or seismic activity, can tell the full story of the volcano's behavior. But by combining all of these data points, scientists can create a comprehensive picture of what's happening beneath the surface. This integrated approach is essential for predicting potential eruptions and understanding the underlying processes at work. For example, an increase in gas emissions combined with ground deformation and rising temperatures could indicate that magma is moving closer to the surface, which would increase the likelihood of an eruption. Conversely, stable gas emissions and a lack of ground movement might suggest that the volcano is not likely to erupt anytime soon. By constantly collecting and analyzing data from a variety of sensors, scientists can make more accurate predictions about Solfatara's future activity and issue warnings if necessary. This real-time monitoring system is critical for ensuring the safety of the millions of people who live in close proximity to the caldera. Solfatara, like many other active volcanoes, is far from dormant. While it may seem like a tranquil, even scenic location to tourists, beneath the surface, the volcano is far from stable. The increased gas emissions, rising temperatures, seismic activity, and ground deformation all point to a greater need for vigilance and continuous monitoring. The scientific tools we have today, GPS, thermal cameras, seismic sensors, and gas analyzers, allow us to monitor Solfatara's every movement. What once seemed like a distant, unpredictable threat is now a well-understood phenomenon that scientists can track and measure in real time. This data not only helps us predict volcanic activity more accurately, but also provides the information needed to protect communities and infrastructure in the surrounding area. As we continue to monitor Solfatara's behavior, it becomes clear that this volcanic system is far from ordinary. Its silent signals hold the key to understanding its future activity, and perhaps even preventing disaster. By staying vigilant and learning from the data we collect, we can ensure that we're prepared for whatever the restless giant beneath Solfatara has in store.